In this video, we demonstrate the use of geosynchronization services by U.S. Army Geospatial Engineer Team, or GET analysts at the Port-au-Prince Airport, and other users outside the Army enterprise. The geospatial engineer analysts are operating under orders to provide medical support, help open lines of communication, and help establish critical life support infrastructure. In this video, GET analysts are represented by the top Gaia application from the Carbon project. These analysts have been assigned publisher roles to synchronization services. The analysts have been tasked to collect and publish data and assume the duties of Geospatial Foundation Data Manager within the area. To support this process, the analysts will be in real-time communication with higher-level Army echelons who will review the published changes and distribute them to web feature services. Please note, the top application shows data from a CubeWerx web feature service, and the bottom application an ESRI web feature service. Both will be geosynchronized in real time using the CarbonCloud service. Geosync feeds are displayed at the left of the Gaia application and features just to the right. We will also demonstrate the use of geosynchronization between enterprises, as simulated USAID publishers contribute information on damaged roads in the Port-au-Prince area. The GET analyst starts his session by reviewing the previous shift's work, and notice that several camp, building, road, airport apron features are missing from the Geospatial Foundation. Please note that the background image is from an OGC Web Map Tile Service, or WMTS. The analyst can enter the missing camp features by selecting the appropriate geographic location. You can also review the attributes of the topographic data model and then stage the updates for geosynchronization. You can also enter a quick note to the reviewer about the new camp updates and submit the changes to the geosynchronization service. The proposed changes are then sent to the Geosync service change feed and appear in the reviewer's list of published changes at the bottom of the screen. The reviewer zooms into the area to get a better look at these new features. He can examine the contents of the updates, in this case a camp, review the properties, and other information. He decides to accept them, and a message is sent back to the analyst in the resolution feed. Good job! And another camp point is accepted. When the changes disappear from the top feed, it means both WFS are being updated. The geospatial engineer can also digitize the missing apron at the airfield. He does this by selecting the feature type, and then begins digitizing the new feature. He drops several points on the screen, and completes the feature by double-clicking. You can add that feature to the geosynchronization process as well. The GET analyst can also take advantage of existing data, such as the CubeWerx OpenStreetMap WFS, to quickly snap to existing features in GML, like a missing road or building. This will help speed up the data collection process. You can review the attributes and stage these features for geosynchronization as well. In this example, he selects the existing building, recreates a new feature in the new data model, reviews the attributes, and stages this for geosync as well. After these features are created, the analyst simply syncs each layer and sends a note to the reviewer about the new buildings. He also syncs the new apron geosurface and sends a note to the reviewer. The new features are now available in the reviewer's Publish Changes feed. The reviewer can check out the new apron feature by examining the imagery. He can turn on and off the feature, and he decides this is acceptable. Again, he can communicate in real time back to the geospatial analyst. He can also review the new building feature, and he accepts that as well. As this process moves along, the web feature services are being updated, and new features will become available on both web feature services. We can see this in action by zooming out a little bit. And you'll see that the new features appear in the screen. First the building, then the new apron geosurface. While the GET analysts are working on proposed updates, other new updates are coming in from outside the Army enterprise. In this example, damaged roads are being collected by volunteers working with USAID or other organizations. These publishers can use the same tools as the geospatial analysts, but they are focused on collecting information about damaged roads in the Port-au-Prince area. The reviewer can also examine these proposed changes, and if they are acceptable, geosynchronize them between the WFS from multiple organizations. Finally, the volunteers are notified that their changes have been reviewed, accepted, and published.